So now we're going to talk about different types of chemical reactions. We will try to understand these 5 different combination, decomposition, single replacement, double replacement, and combustion. So these 5 basic reaction types are the ones that we're going to be dealing with. We're going to basically write down the equation and balance it and just look at some reactions. So for a combination reaction, we will actually go over it at the very end. Okay. I will add the video to the very end of that one. So we're going to jump into the decomposition reaction right away. So in decomposition reaction, I'm going to demonstrate you the breakdown of water using electrolysis. So essentially, we have water, and we will subject it to the electrical current. So what you see on the camera is the electrolysis apparatus. You can see closer to the bottom are 2 electrical cables, positive and negative, that are attached to that electrolysis apparatus. And as water will be broken down, the gases will be accumulating on top of the tubes. So without further ado, let me start the electrolysis. So you can see very clearly here, okay, you can see the bubbles of gases going through. See that? And these gases accumulate at the top, right there. So we're going to give it a run for several minutes, and then we will check how the volumes of the gases relate to each other. So we stop the reaction, and the ratio, it's not really super clear. I will try to come closer. So here we have the displacement of about 4 milliliters of gas, and here we have a displacement of about 2 milliliters of gas. So if we go back to our conversation here, okay, so 2 gases that are formed during the decomposition of water, what are those going to be? So if you have water at H2O, then 2 gases that are formed are going to be hydrogen and oxygen, right? It's not a balanced equation, don't take it. So the volumes of 2 gases, how do they compare? One gas is, there's twice as much as another one. So if we will balance this equation, which gas will be in the larger quantity? Hydrogen, obviously. Okay, so the volume of hydrogen that is produced based on the equation is 2 times larger. Okay, so you're supposed to write down this equation. Why is this reaction called a decomposition? Because water decomposes into hydrogen and oxygen. Good, clear?
Yes. Now, before you said hydrogen was the gas, the largest.
Yes, the hydrogen is the gas with the larger volume, you know. And so in regards to this question, indicate which gas was attracted to the positive and negative electrode. What I can tell you is that the positive electrode, which was red, had smaller amount of gas attracted to it, and negative electrode, which was black, had higher amount of gas attracted to it. So based on your knowledge, which was a large amount of gas and smaller, and that, you know, red had smaller and black had larger, you can figure out which one was attracted to which. So the next type of reaction that we're going to talk about is single replacement reaction. We're going to place a small piece of magnesium into the test tube and add about 5 milliliters of hydrochloric acid. Then we're going to look and see if there are any signs that reaction is actually still going. And when reaction, it will be going pretty vigorously, we'll fire up the splint and bring the flame to the mouth of the test tube and see what's going to happen. And then we will try to answer these questions. So here I have a fragment of magnesium in the tube, and I have hydrochloric acid, and I'm going to combine them. So let's take a look if reaction is going on. And it definitely does, because there is gas being produced. Now let's see what happens if I will light the splint. Oh, you see? That pop was whatever gas is being produced burns almost immediately. There's no accumulation there. But you got the gist. Almost gone now. What you can actually see is that magnesium practically dissolved, completely dissolved in hydrochloric acid. So let's answer some questions. When magnesium interacts with hydrochloric acid, the gas that you were observing before was hydrogen gas, and another product is magnesium chloride. It is up to you to write the products. The gas that was formed in test tube was hydrogen, and this was the interaction of hydrogen and oxygen. This is why you heard this tiny little bang. So let's move on and chat about double replacement reaction. Sometimes it is called an exchange reaction. So we're going to mix copper 2 sulfate and sodium hydroxide. Okay? And then we're going to see what happens. Obviously the precipitate is going to be formed. And then we're going to write the reaction and explain why it is called double replacement reaction, unlike this one, which is a single replacement reaction. So here we have 5 milliliters of copper sulfate, and I'm going to add 3 drops sodium hydroxide. 1, 2, 3. So here's what you've got. You see, there's some precipitate formed, and I keep on carefully shaking it. So there's a substantial amount of precipitate. Formed in the tube. So what happened in this reaction? So you've got copper 2 sulfate interacting with sodium hydroxide. And I'm not going to balance this reaction. So what you get is copper hydroxide. I do not add any subscripts, it's entirely up to you. And sodium sulfate. Sodium sulfate is soluble, while copper hydroxide is not soluble. So this was a precipitate. Why we call it double replacement? Because you see copper replaced sodium, okay, in this molecule, and sodium replaced copper in this molecule. Sometimes those reactions are called exchange reactions. Now in this reaction, magnesium plus hydrochloric acid, the products are magnesium chloride. Again, no subscripts, you figure it out by yourself, okay? Now maybe there's a subscript, maybe there's not, but you should add the subscript. It should be in this molecule, there's one, but here you can see that magnesium replaces only hydrogen. So the next reaction that we're going to talk about is the combustion reaction. So we're going to light the candle, and then when candle is lit, we're going to put a beaker on top of the candle and see what happens to the flames. And we're going to answer the question, which gas in the air is necessary for combustion to occur. And then we're going to try to write the proper formula here. So you can see flames, you can see the beaker. I'm going to put it right here. And bam, the flames went out. So I don't think it will be something completely new to you, but it's oxygen that we need for the combustion to occur. And if you put oxygen here, you will need to balance this reaction by yourself and submit it with the lab. So lastly, we're going to look at the combination reaction. After this conversation, you will see actual burning of magnesium. So magnesium, as you already saw, is pretty shiny, and what you see after it's been burned is going to be pretty much a bunch of ashes. So the formula, okay, so when magnesium burns in oxygen, you get magnesium oxide, Whether or not this molecule requires subscripts is up to you. You need to figure it out using, the charges for magnesium and oxygen. And then you have to balance this reaction. Now, why is this reaction called a combination reaction? Because you have two chemicals, magnesium and oxygen, combined to form one. So what we're going to be doing now is burning magnesium. Look what happens. And this is how it looks after the burn. And this is how it looks before the burning. So finally, it is up to you to go through the lab review. Ask me if you have any questions, but you need to balance these 5 equations here, and you have to identify and write next to each of the reactions what type of reaction this is, whether it's a combination reaction, decomposition reaction, single replacement reaction or double replacement reaction or combustion. from what I can see, there is a mistake here. So it's going to be zinc plus copper SO4, and the products, you will have to kind of figure out. Do not hesitate to. So I can kind of give you a hint here. So when hydrogen and chlorine interact, they form hydrochloric acid. In this case, it's going to be zinc sulfate plus copper. In this case, it's going to be aluminum chloride and water. You don't need anything here, and you don't need anything here. So you go for it, and you balance it out and submit together with your labs 6, 7, and 8. I hope that makes sense.